Hello, this is Mr. Stansbury. I'm going to take you through the 13.1 worksheet on solving a system graphically. Okay, on this here, we're going to solve each system graphically, which means we're going to draw these two graphs and find out where they intersect. So the solution is where they intersect. Okay, so pretty important to draw good graphs when we are trying to solve graphically. So let's do this. Let's first start with our x squared minus 4x plus 4. Let's graph that, and that's just like what we've been doing for this whole unit here, graphing quadratics. So let's find our vertex, right? And we'll find that by using negative, well, x equals negative b. Let's write that up here. X equals negative b over 2a. That's going to give us our axis of symmetry and also our x value of our vertex, right? So we get x equals negative 4 over 2 times a. So remember, we're just dealing with this equation right now. We'll deal with that one later. So negative 4 is our b and 1 is our a. So we get x equals 4 over 2. So x is 2. So we've got an axis of symmetry right here at 2. And then to find the y value, remember we're going to plug it back into the equation. So we get y equals 2 squared minus 4 times 2 plus 4. 2 squared is 4. Negative 4 times 2 is negative 8. Plus 4. So 4 plus 4 is 8. Minus 8 gives us 0. So the vertex right here is at 2, 0. Okay? From there, there's a 1 out front here. So we're going to go up 1 over 1. Up 1 over 1 that way as well. And then we need to come up with 2 more points, one on either side. So either at 0 or 4. I'm going to plug in 0 because that seems like that's going to be a lot nicer. So y equals 0 squared minus 4 times 0 plus 4. That turns into 0. That turns into 0. So our y-intercept, or our y value at 0, which is also our y-intercept, is 4. Okay? Reflect that across our axis of symmetry, and there's our other one. Okay? Now, since we're trying to find the intersections with a graph, we're going to really want to try to draw this as best we can. So I'm going to try my darndest to make this a decent-ish graph. Okay, that's decent enough, but I really want these to go through. That's pretty close. Okay. Now, for this here, this is a linear equation, so we're just going to graph by using like this is y equals mx plus b, right? The b is our y-intercept, so it starts at 4. And then our slope is negative 2. So from here we go down 2 over 1, down 2 over 1, down 2 over 1, and then we draw ourselves a nice straight line right through there. Okay, so I thankfully have this nice little cheater option where it'll help me draw a straight line. It does not help me draw parabolas, as you can tell. Okay, and then now from here, we can now see that they intersect at 2 spots, right here and right here. So our two solutions are at 0, 4. So that's the coordinate of that first intersection. And then this intersection here is at 2, 0. Okay? So those are our two solutions. That's where the two graphs intersect. Okay? All right, let's take a look at number 3. I'm going to do the same thing. Vertex x equals negative b, which in this case is negative 4, all over 2 times a, which in this case, remember, just this one we're dealing with. It's 2 times, there's a 1 out front there. So we get x equals 4 over 2. So x is 2. So there's an axis of symmetry right here at 2. Now to find the y value, we plug that 2 back into the equation, and we get y equals 2 squared minus 4 times 2 plus 3. 2 squared is 4. Negative 4 times 2 is negative 8. plus 3. 4 plus 3 is 7, minus 8 is negative 1. So our vertex is at 2, negative 1. Okay, to find our next point, we're going to use this 1 in front here, up 1 over 1, up 1 over 1, up 1 over 1 the other way, and then we can plug in either 0 or 4. If we plug in 0, that's going to make our life a little bit easier. Y equals 0 squared minus 4 times 0 plus 3. Those turn into 0, so our y in this case is going to equal 3. So when x is 0, y is 3. So also, that's 2 units away from our axis of symmetry, so go 2 units past that, and there's our other 5th point. Try to draw this as best you can. Decent-ish, not perfect, but we're just going to have to go with it. And then now the second thing we're going to do is graph this this straight line, by starting at 3, so our y-intercept at 3, and then this is a 1 here too, right? So we go up 1 over 1 from there, up 1 over 1, up 1 over 1, up 1 over 1. Okay, now this is going to be a little tricky because this graph is going to run across here at some point, but we can't really tell where it's at. Okay, because my graph is not beautiful. So we know for sure one of the solutions is going to be at 0 and 3, right? Because that's this point right here. There's going to be another solution somewhere up in here. We don't know exactly what it's going to be. My guess, if I'm guessing on this, it's probably going to be at 5, 8. Let's just check and see if 5, 8 works in here. Because again, my graph is not pretty enough to get that going. So if we plug in 5 into this here, what do we get? So y equals 5 squared minus 4 times 5 plus 3. So we get 5 squared is 25. Negative 4 times 5 is negative 20 plus 3. So 25 plus 3 minus 20 happens to give us 8. So this, our quadratic graph here, the next point over is actually going to be right here as well. So this graph is actually going to come right through like that. So that means that 0, 3 and 5, 8 are going to be our two solutions. Okay, so you can kind of tell here why solving by using hand-drawn graphs is not the best idea, because it's hard to know exactly where these points are. Okay, it can be done, but there's a better way, and that's 13.2. Okay, that's coming up. Anyway, if you've got any other further questions on this, please feel free to ask in class. Thanks.